Welcome back to the Science Shed, and this is episode 6 of a series of videos which are designed to help you revise your GCSE physics if you are studying in England. If you're not in England, I hope the content is useful because the physics will be correct wherever you're living, but you will need to check your curriculum to make sure it covers what you need to know. And if you are living in England, please don't rely on all these videos as your only source of revision. Check your syllabus and make sure that you've covered everything that you need to know. We're going to start a new topic today. So we've looked at energy, now we're going to start electricity, and as we're revising electricity, we're going to look at some of those things that you would have learnt when you were studying science before you started your GCSE. So it's some of the basic things that you need to know. Let's make a start. In order to understand electricity at all, you need to know about electric charge. And here's what you need to know about charge. You need to know that there are two types of charge, and we call them positive and negative. And those charges exert forces on each other. They push or pull each other. And the way it works is, if the forces are the same, or rather if the charges are the same, they push apart. So positive and positive push apart, negative and negative push apart. But if the charges are different, they pull together. We say opposite charges attract, and that like charges or similar charges or the same charges repel. Repel for push apart, attract for pull together. And you might be wondering how objects pick up charges like positive and negative charges so that they can do this attracting or repelling. And the truth is that everything contains both positive and negative charges. Everything is made of atoms, and atoms are made of three different particles: electrons, which have a negative charge, protons, which have a positive charge, and neutrons, which are neutral. They have no charge. Clues in the name. If you want to remember which way round it is, just remember proton starts with a P, and so does positive, so it's the protons that have the positive charge. And in most atoms, you get this situation, which we've got in this atom, where the number of protons and the number of electrons is exactly the same, and therefore the charges balance out, and overall there's no charge at all. And that's why most objects don't have a charge. They contain positive and negative charges, but they don't have a charge. But it is possible for objects to pick charges up, and that very often happens when two objects are rubbing past each other. So let's have a think about how that might work. Here we have a cloth that's made of a fabric, and we have a rod. And in this particular instance, when the cloth rubs along the rod, some electrons move from the cloth to the rod. Now, if that happens, and it's illustrated in this diagram, there will be more positive charges in the cloth because some of the electrons have moved away. Before the rubbing, the number of protons and electrons was the same. When the electrons are rubbed off onto the rod, we've got extra protons now because we've lost some electrons, and the cloth will pick up a positive charge. The rod has extra electrons because they moved from the cloth. So that's picked up a negative charge. And that's what rubbing does. It transfers electrons from one substance to another. And it isn't always the cloth that picks up a positive charge and the thing that's being rubbed with the cloth that picks up a negative charge. It really depends on what the cloth's made of and what the other substance is made of as well. But this rubbing can cause things to pick up charges. You also should have learned when you were studying science before you started your GCSE what an electric current was. And basically a current is a flow of charge. If the charges that we've been talking about are moving, that is a current. And almost always, and in another video we'll see the exception, but almost always the current is charge that's moving because it's being carried on moving electrons. There's a really good simulation of what happens in electric circuits. It's called the Circuit Construction Kit, and it's produced by PhET. and I will put a link to that in the comments for this video so you can have a go at it yourself. But this video shows really nicely what's going on. It shows electrons in the circuit moving, and that's what the current is. So what the power supply is doing is it's pushing electrons out of the negative terminal and it's pulling electrons into the positive terminal, and it's moving them through the power supply. And then once they've been pushed out of the negative terminal, they move. Let's get it going again because that's stopped. So let's play the video again. They move all the way around the circuit through every component. That's what a current is. It's always moving charges, and it's almost always moving electrons. So that shows us very clearly what an electric circuit is. Conductors and insulators you will have learnt about as well. So basically metals are good conductors of electricity and non-metals tend to be insulators. And it's all to do with whether the electrons can move. In metals, some of the electrons are free to move. They're not firmly stuck to the atoms like they are in non-metals. They're free to move. That's what makes metals conductors. Now, there is a video of an experiment where I test the conductivity of some everyday objects, and if you'd like to watch that video, then what you need to do is to find it. It will be posted clearly there. But let's have a look at a simulation of that experiment. So this is using the same circuit construction kit, and what you can do in this circuit construction kit is you can set up a circuit here with a gap in it, which is what we've done. So we've got a power supply, we've got a lamp that will light if the current is flowing, and then we've got a gap, and then we can put different things in the gap. So if we put the piece of paper, which is said to be a dollar bill, no current flows. Now look, there are electrons in the paper, but they can't move, and that's what makes it an insulator. However, if we take a paper clip instead, which is obviously made of metal, we do get current flowing. And that's because in the paper clip, the electrons can move. The electrons are free to move. Let's try replacing the paper clip with a coin. If you've been paying attention, you will know that a coin is metal, and that in metal the electrons are free to move, so it will be a conductor. The current's flowing, the bulb's lit, the coin is a conductor. But the eraser, that's made of a non-metal, it does contain electrons, you can see them in the diagram, but look, no current is flowing. It's because the eraser is a non-metal and the electrons are not free to move. Let's try a hand, part of your body. I'm not quite sure how you would put this in the circuit. I don't think you cut your hand off to do this experiment. You might just put your hand in the circuit with the rest of, leaving it attached to your body, and you can see that neither your hand nor a dog will conduct electricity. They don't let electrons move. What about a pencil? What do you think is going to happen with a pencil? Should we collect it in the circuit and see? So let's put it in the circuit and watch carefully what happens. So look, can you see the bulb is lit and the electrons in the circuit are moving very slowly? And the reason for that is the lead of the pencil. It's not lead. If you thought it was lead, you'd think it was a metal and you'd think, oh yes, that is going to conduct electricity. But the lead in the pencil is a material called graphite, which although it's a non-metal, it does have electrons that can move, but they can't move as freely as they can in the metal, so the bulb doesn't light as brightly. So key idea, you can divide materials into conductors and insulators. Metals are conductors, most non-metals are insulators. Okay, let's go on to the next slide. If you watch the video where I was testing the different household materials to see whether they're conductors or not, you would have heard me talk about cells and batteries. So I think it's a really good idea to make sure you know the difference. In everyday speech, what we call batteries almost always aren't batteries at all. They are in fact cells. If it's one thing, like this thing here on its own, and it produces a voltage of, let's say, 1.5 volts, then it is a cell. It's only a battery if you put lots of cells together. So actually these 8 cells here in this holder make up a battery. That's a cell, that's a cell, that's a cell, and so on. All of them together is a battery. So a battery, a cell is one on its own. A battery is 2 or more cells connected together. And we normally do that to get a bigger voltage. You can't really, with a cell, get a better voltage than 1.5. So 1.5 volts is about the best you can do. If you want more, so this is 12 volts, what you've got to do is you've got to connect them together. There's 8 of them, and each of them gives 1.5 volts. 1.5 times 8 is 12. And this actually is a battery, and I can tell it's a battery because it's got a voltage of 9 volts. What that means is if we were to take it apart, and please don't take it apart, if you try to take it apart, the metal, you'll have sharp metal edges, which you could cut yourself on, and the contents of the cells contain chemicals which can be corrosive. So please don't take it apart, but if you did, you would find inside there were 6 cells connected together to give you the 9 volts, and that's why it's a battery. It's more than one cell. So that's the difference between cells and batteries. And I thought it would be useful actually to have a go at making a cell, because you can quite easily make a cell. Basically, if you want to make a cell, one way of doing it is to take 2 different types of metal. Here we've got aluminium and a steel bolt. And then if you put them in a container with something that's going to react, like an acid, malt vinegar is a weak acid, then you have made a cell. And you can see that this cell here that I've made is producing a voltage of 0.365 volts. So it's not a particularly good cell, certainly not as good as the cells that I used in the circuit, but it's a cell nevertheless. And this is what, and I hope you're asking yourself, what is a cell like inside? This is what a cell like is like inside. So in the middle of the cell, we've got a carbon rod, and there's a metal cap, so it will connect into the circuit, and that will be the positive end of the cell. You've then got some manganese oxide, which doesn't take part in the reaction. You've got some ammonium chloride paste. And like vinegar, ammonium chloride is a weak acid, so that's involved in the chemical reaction. And then on the outside, you've got some zinc. So those 3 chemicals together, ammonium chloride, zinc, and carbon, are the things that react to produce the voltage that the cell gives. And the voltage is mostly determined by the 2 chemicals, so by zinc and carbon, and that's why you can only get about 1.5 volts from a cell. What do they do? Well, they transfer energy. I'm not sure this title is entirely accurate. I would say circuits would be better. So a circuit transfers electrical energy. So the cells, if you remember the energy topic, they've got chemicals inside, as we've just seen on the last slide. They store energy in a chemical store. And when you connect it into the circuit, that energy is transferred electrically to, in this case, a bulb, and produces thermal energy and light. You also, before you even started your GCSE, would have seen some of the symbols that we use in circuits. So you will have seen a cell. I'll explain what that is. If we were drawing a battery, if we were looking at that battery that I used in the circuit before, we could, look, there's 8 of them. 1, 2, 3, count them. We could draw this 8 times. That would be a battery. But we have a symbol to save us having to draw this lots of cells. So we draw the first cell and then a dotted line to show that there are more cells, and then the last cell, and then we would put what the voltage of the battery was above it. So that's the symbol for a battery. This is the symbol for a lamp. A resistor is a component that it's deliberately difficult for current to flow through. That's what its job is. A voltmeter is used to measure something which you might at GCSE have called voltage, but it's more properly called potential difference. An ammeter is to measure current. And then we've got some switches with some confusing names. So what physicists have done is they've looked at these diagrams to show switches, and they've said, oh, well, that's like a door or a gate looking from above. And here it's open because somebody could go through. And here it's closed because nobody could get through. And the closed switch is the one that completes the circuit. It means that it's on. And the open switch is off. And I think that can be a bit confusing. So just make sure that's clear in your head before you go on to the next bit. So if it's not clear, pause the video, just rewind a bit, listen to that explanation again. And the last thing that you'd have learnt at Key Stage 3, or maybe even at primary school, is that there are different ways of connecting more than one component to a power supply. So you could connect them what's called in series, and if you connect components in series, you simply put them one after the other. So this is 3 lamps connected in series, and you can see they're really dim. In fact, you may not even, until I pointed it out, have noticed that they were glowing at all. And the reason for that is we've got 12 volts for this power supply, but those 12 volts have to be shared between those 3 lamps. They're only getting 4 volts each, and that's why they're dim. They're not getting the 12 volts they're designed to work with, they're only getting 4. There's an alternative. You can set up a circuit with some branches in it. So let's have a look at this circuit. It's coming out here. We've got the positive end of the battery. And then at this point, the circuit divides. So current can flow, or the electrons can flow this way and back to the power supply. Or when they get here, they can go this way if you preferred and go to that bulb. Or when they get there, instead of going to that bulb, they could go along and go to this bulb. And this is called a parallel circuit. And you can straight away see one of the advantages of a parallel circuit. These bulbs are much brighter. And the reason they're much brighter is because they're getting the full 12 volts of the power supply. So they're working properly. Whereas in the other circuit, they were only getting 4 volts, so they weren't working properly at all. These diagrams show you what they look like if you draw a circuit diagram for each of those arrangements. And this is quite useful for looking at the effect of switches. So in this circuit, if we wanted all the lights to come on, we would have to close all of those 4 switches. If any of them are open, so let's say we close that one and that one and that one, but we leave this one open, there's a gap in the circuit, and that means none of the bulbs will light. So with a series circuit, we can either have all the bulbs on or we can have all the bulbs off. But a parallel circuit is much more versatile. If we close this switch and then we close that switch, we can turn on this lamp but have these 2 off. And then if we open this switch and close those 2, we can have those 2 on but this one off. Or as long as we've got this switch here closed, we'll talk about this switch a bit more in a moment. Or we could just close that switch and have just this lamp on. If we wanted to turn them all off at the same time, we could close all of those 3 switches but open that one. So that switch can control all 3 of them. These switches control each individual bulb. So if we were to summarise the advantages and disadvantages of each type of circuit, here's how we would do it. The advantage of a series circuit is that it's simple to set up and it's cheap because it uses less wire. But it's got some important disadvantages. So if you add more components, they get less voltage, and for bulbs, that means they're less bright. And all the components are either on or off. You can't switch them on or off individually. And that also means, for the same reason, if one of the components fails, if it stops working and it no longer conducts electricity, then all of the components go off. And you don't actually know which one's broken. You have to test them all because they've all gone off. So you don't know which one's caused the problem. Whereas with parallel circuits, we've got lots of advantages. Each component gets the full voltage of the supply. So however many components there are, you can add them and they're going to work properly. You can add lots of bulbs and they're not going to get dimmer. And you can switch the components on and off independently if you want to. And if one of them fails, it stops working, but the others continue to work. And the only disadvantage really of parallel circuits is they're a little bit harder to set up, and because they use more wire, they're more expensive. So that's the information that you would have learnt, the basic information you would have learnt before you even started to study GCSE. I hope it was useful for your revision, and if it was, please give this video a thumbs up. Don't forget, if you want to see household conductors and insulators, to watch the video about that. I've really enjoyed explaining to you about the basic ideas to do with electricity, and I'm very much looking forward to explaining some more about electricity in the next episode. Until then, good luck with your revision.